Okay, thank you very much for the patience. So let me take the profile of our dear mentor. Okay, so for our mentor's introduction, confirm you can still hear me.
Yeah, loud and clear.
Yes, ma'am.
Okay, thank you very much. So for our mentor introduction, Mr. Uchechukwu Imo is a geophysicist with CB Geophysical Solutions. He has a Bachelor of Technology degree in geology and a Master of Science in Sedimentary and Petroleum Geology from the Federal University of Technology, Owerri. He has vast experience in hydrogeology and field mapping within the Anambra Basin, as well as over 7 years experience in the oil and gas exploration within the Niger Delta Basin. Mr. Uchechukwu works with a dynamic and multinational team of subsurface experts that has carried out several seismic data processing and interpretation projects still within the Niger Delta and beyond for both international oil companies and marginal field operators. With clapping emojis, let's welcome our dear mentor. Please, I want to see your reaction in the chat box. Let's welcome our dear mentor, Mr. Uche Shuku, who enjoys learning, teaching, and mentoring. You can see he loves mentoring. That is why he's available to take this session. You know, if you want to learn seismic in the industry, you pay heavily for it. So for this session that you're learning seismic for free, from the beginning of the concept of seismic to the interpretation of seismic, for those that are geophysicists, you know how difficult it is to have access to all these training materials, specifically in seismic, and you are getting this for free. Please, let's use the chat box. I'm not seeing anybody commenting, so let's use the chat box to welcome our dear mentor, Mr. Uche Shuko. Please, Mr. Uche, you can go ahead. I will make you the host of the session. Then you can make me a co-host just in case I log off. Thank you very much, sir.
Okay. So, good evening, everyone. Thank you so much for your time and having me here today. This is our energy mentorship program handled by Lecture Hub, and this is the second edition. And for us in seismic acquisition and interpretation, this is our first session. So it's more of a kickoff session for us. And today we are not going to be diving deep. We'll just get to introduce ourselves and know ourselves. For me, as a mentor, over the years, I've been doing mentoring in the industry. I start by understanding who I'm talking to. So I would like to have a brief introduction of yourselves. You tell me your name, you tell me your course, the course you studied in school. I would like to have an idea of our demography, where you are currently in this call. And that would be that. And if possible, you can tell me if you're still in school or you graduated. That will help me have an idea of the people I'm talking to. So who will go first? Our moderator, can you start?
Okay. Good evening, everyone. Good evening, sir.
Yeah,
my name is Daniel.
Okay.
I stay in Lagos. I graduated from Ambrose Ali University. My course of study was. I graduated in the year 2022.
Okay. Your course of study was what?
Geophysics.
Okay, geophysics. Okay. Okay. Daniel. Next person, please.
Okay, sorry. So since Daniel is the moderator, Daniel will be the one to appoint names from his own end, so there will be orderliness in the meeting. So Daniel, you have a whole lot of work to do this evening. So you'll be the one to moderate who to speak first and who should use maybe the chat box. So thank you.
Okay. Can we have Adigun Kudus Bolaji?
My name is Kudus Bolaji Adigun. I'm a geophysicist graduate from the University of Benin. I'm currently undergoing my service here in Bonny Island, Rivers State.
Okay. You're welcome, Kudus.
Thank you very much, sir.
Yeah.
All right.
Next
Thank you very
person, please.
Okay. Please, can we have you?
Good evening, everyone. Good evening, sir. My name is Anthony Nwafo. I study geophysics at applied geophysics at Nnamdi Azikiwe University. I graduated in 2022. Currently, I'm in Oka.
Okay.
I'm graduate in 2016. Thank you, sir.
Okay.
Thank you very much, Anthony Nwafo. Okay. Ed Messi Nkechi. Can we have you?
Good evening, sir. Please confirm you can
Good
hear
evening.
me.
Yeah, I can hear you.
I am so sorry about my lateness. I am so sorry. I had network issues.
No, go ahead.
I am so
Go ahead. We're just starting. Go ahead.
all right. Thank you so much, sir. So I am Edame Sinkechi, and a recent graduate of University of Nigeria in Nsukka. And I'll be the moderator for this class. Thank you, sir.
What did you study? Messi,
I studied
what did
geology,
you study?
sir.
Okay, geology. Okay. So, next person, please.
Favor Ajike.
Good evening, sir. My name is Ajike Deborah. I'm a final year student of applied geophysics studying at Nnamdi Azikiwe University.
Okay. Next.
Okay. Ikide Emmanuel.
Okay, good evening, everyone. Good evening, sir. My name is Ikide Emmanuel. I'm a recent graduate of Federal University of Petroleum Resources, Delta State. I graduated last year with applied geophysics. So I'm currently in Delta State.
Okay. Next person, please.
Jenny Adibe.
Good evening,
Good evening.
everyone. My name is Jenny Adibe. Yeah, I graduated from Geology Department, University of Calabar in 2023, and I'm currently in Thank you.
I can barely hear you, Jenny. But if I made it out, you have a BS in. Yeah.
I said good evening, everyone.
Good evening. Yeah.
Good evening.
I can hear you now.
Can you hear me? Can you hear me?
Yeah, I can hear you now.
I studied geology from the University of Calabar.
Okay.
I graduated in 2023, and I'm currently in Port Harcourt.
Okay. Next.
Okay, Jenny James.
Good evening, everyone. Good evening, sir.
Yeah, good evening.
Jerry James Moral from, I graduated from Odibo University, Yola, formerly Federal University of Technology, Yola. I'm a geology graduate and I'm currently serving in Delta State. Thank you.
Okay.
Okay, Unizik Juliet Oluebube. I'm not sure she's here. Juliet, are you here? Okay, what of Shibong Lydia?
Okay. Hello, good evening, everyone.
Yeah, good evening.
Sorry, I just joined. Please, what are you talking about?
Introduce yourself, please.
Okay.
Tell us your name, your course of study in school, and the school you graduated from.
Okay, my name is Shibong Lydia. I'm a recent graduate of geology from University of Jos. Yeah, and I'm excited to be part of this program.
Okay. Another person, Daniel.
Yes, sir. Okay, no, we still have one. Azan. Juliet has not responded. Yusuf Azan.
Good evening, everyone.
Okay.
So my name is Yusuf Hassan. So I finished my my BSc from Federal University of Technology, Akure. Then I did masters at ABU Zaria, all in applied geophysics. So I currently work in Lagos.
Okay. Welcome, Hassan. Any other person?
I think Juliet is the last person here, and she's not responding.
So I have 10 persons that have introduced themselves, and we are 14 on the call. So 3 persons have not introduced themselves. So if you're just joining, we just did a brief introduction of ourselves. Today is our kickoff. We're not going to be talking much. I just want to have an understanding of everybody here. And we are all recent, you all are all recent graduates, and some few maybe still undergraduates. And the good thing is that you all are in the geoscience field. From my list here, geology and geophysics. And so we'll be talking about the seismic data for this mentorship program. So I believe you saw what I posted in the group. I sent a picture that shows the objective. I won't be sharing any slide today. Did you see the picture? If you saw it, let me know. Can anybody agree that they saw it? I posted something before.
Yes,
now.
sir, I saw it. Yes, I saw it.
Okay. So that's for me, the aim of this program, organized by Lecture Hub, I believe, is to bridge the gap between the classroom and the industry. One thing you understand and you agree with me, I know all of you have heard about Seismic, one way or the other in your lecture halls or in your classrooms from your lecturers, especially our brothers and sisters who have their degrees in geophysics. You've all heard about the seismic data. And for us in our Nigerian universities, well, you know that our universities do not give in-depth knowledge into seismic method to our students. And sometimes you see students, they come into the industry and they are always kind of lost when it comes to the seismic data. For those of you who have come in contact with seismic data, one thing that is very common is you always do that in the interpretation end of the data. So for let's say Yusuf, who has an MSc, if you may have not you may have been more versatile or more exposed to interpretation and all that. Your stack sections and how to interpret, how to use Petrel and all that. Yeah, for me, that is the end of the line, one end of the spectrum when it comes to interpretation. So the essence of being here is to bridge that gap so that you have a wider and broader understanding of your seismic. And then by the objectives, I would like to teach you or take you through the seismic method, the fundamentals, because we have a lot of students who have seen or heard about seismic data, but they don't understand the fundamentals. How did this data came about? How do we acquire it? Before you even acquire it, what happens and all that. So for our friends who are geology graduates, they may not have more on knowledge about seismic. For me, I read geology first degree and the master's level, but I was opportune to be in the industry where seismic is being processed. So it gave me a leverage to better understand the data. So seismic is very robust, it's very broad. So at the end of this lecture series or our program and internship series, I expect that we'll have a better understanding of the seismic method from rudiments. Because one thing about me, and I believe most of you agree with me, is that when you want to learn anything, you start from the rudiments, the fundamentals. One. So that is one. Then number two is you get to understand or learn how seismic data is acquired and currently in the industry and industry trends. And then thirdly, you get to know how seismic data is processed. I'll take you through the basics, which I believe most of you may not have an idea of because it's a topic that is rarely talked about mostly in our universities. So I'll try my best to bridge that gap so that you understand how your data is being processed and to come to the end user, who is the geologist and the interpretation geophysicist and geologist who uses this data for interpretation purposes. Then last but not the least, I'll also try my best to attenuate any fears. You all are fresh from school, and one way or the other, you're going to be joining the industry as interns or as trainees and entry-level geologists or geophysicists. Whichever way, whether you're joining the industry, the oil and gas industry, you are going to do your MSc in maybe energy transition, stuff like carbon capture and storage, geothermal energy, maybe outside the country, you're going to come across seismic data. That is the truth, because seismic is vastly being used. Even if you're going to end up outside any of these applications of seismic, you want to go into geohazard assessments and other things like engineering applications for seismic. So whichever way, you end up coming in contact with seismic data. And so by the end of our program, by September ending, my aim is that you have a better understanding of the seismic data, and you will be able to stand and answer any questions as long as entry level is concerned in the industry. Okay? Any question they pose to you, as long as seismic data is concerned, I will try my best to see that you have a better understanding of it. So that is the aim and objective of this mentoring circle or this mentoring program. So in continuation, I know all of us have had know what earthquakes are. I would like our class to be interactive. We all know what earthquakes are, right?
Yes, sir.
Yeah.
Yes, sir, we do.
So we know how earthquakes occur. We know that they occur within the within the Earth's surface when rocks are undergoing stress and strain, and these rocks are deformed, and then they generate what? They generate waves, right? So these waves that are generated, I dropped a link on the group. You can just read it up. The waves that are generated are the seismic waves, right? So since ancient time, earthquakes have been happening across the earth, across the globe. And initially, people used to think they were from some kind of divine activity or miraculous activity or whatever that is shaking the ground and all that. But so over time, came to understand that they are natural phenomenon that are destructive in nature. But at the same time, we came to find out a way to tap into this knowledge. So instead of just looking at it from the angle of destruction of the earth through earthquakes, mankind and the scientists decided to use the method of seismic for benefit of man, okay, for exploration purposes. So that is what brought us to the point where we are now studying seismic method in terms of exploration. So for us, we'll be learning and diving deeper into seismic method as used in exploration. But one thing is common, whether seismic as an earthquake or used artificially by man for exploration purpose, one thing is common, and that thing is the seismic wave. And I believe all of us have heard about waves before, right? So the seismic wave that is generated, whether artificially for exploration purpose, they have physical properties, and there are different types of waves. So generally, we have the body waves, okay, which comprises of your P waves and your S waves. And then we have the surface waves. I believe our geophysics brothers and sisters have a good understanding of what I'm talking about. And we have the surface waves, okay, which are the Rayleigh and the log waves, which I'm sure you must have come across in several of your studies. These waves, for us in seismic method of exploration, applying seismic method for exploration purpose, we do not use any of the waves except the body waves. We don't use the surface waves, which are the Rayleigh and the log waves. The Rayleigh and the log waves, if you look at the link I sent you, they are the ones that are destructive during an earthquake, okay? They are not longitudinal, they are transverse in nature, so they are destructive. But for the body waves, the P wave and the S waves, conventional seismic applications uses the P waves. I mean, I know some of you will be wondering, no slides, and we'll get to slides, and we'll look at slides from our next class. But today is more like a kickoff and an introduction, and bring your mind into what we'll be talking about. I have my slides, but by next class, I'll start sharing them. So for our P waves, which is the conventional waves that we use in the seismic method of exploration. Why? Because they are very fast. They are the fastest of all the seismic waves, followed by the S waves. And the P waves are waves that travel through solids and both liquids. Both fluids, solid and fluid. So the seismic wave, when they travel through solids and fluids, the P wave is the one that does that. When you shoot your seismic wave, your S waves will travel only through your solids, and they will not travel through your fluids. They are also useful in the seismic method of exploration, but for advanced studies. When we get to acquisition, I will explain that further. So conventionally, that is it. And if I may ask, if I may ask, why do you guys think that we do seismic exploration? We use seismic method in geophysical exploration. Can anybody give me an idea, a hint? I want to know. Anyone? Feel free, please. I'd like you to interact with me. Feel free to talk to me. Tell me what you think.
Okay, sir, can I try?
Yes, try, please.
Hello, sir, please, can I try?
Yes, please try.
Okay, I would say because of its deep penetration into the subsurface.
Okay. That is one good reason why we use it. What else? Any other one?
Okay, so I want to try, sir.
Yeah, go ahead.
Because it is directly or indirectly, it has relation with velocity.
Okay. It has relation with velocity, okay? Yes, you're right. It has relation with velocity. That has to do with its the property of a wave. Every wave has a velocity that it uses to propagate through a medium. So fine, that's good. So what other reason why do you think I use seismic method in exploration? Any other idea?
I guess the resolution also.
Resolution. Okay. Resolution. Resolution to an extent, but that is quite ambiguous to say at this stage because resolution is one of the limitations of the seismic method. Resolution is one of its limitations. So what else? There's one major reason why the seismic method is.
Okay,
yeah.
Okay, sir. Okay,
Mm-hmm.
I feel I want to just add, since
Go ahead.
P waves can travel to both, propagate through both solid and liquid, and S waves cannot propagate through liquid. I think it can be used to determine the presence of fluids.
Okay. Yeah. It's yes. Okay, that's a good reason. The different waves. When you do a particular type of seismic survey, where both S waves and P waves are recorded, it helps you for monitoring your reservoirs because your reservoirs contain fluids. That's a good reason. But the primary reason, I think I've logged in 2 places. Okay. How do I exit this one? The primary reason being that the seismic data gives you wide area coverage and it has good depth of penetration. Okay. It has a good depth of penetration. Okay. Showing myself in 2 places. How do I get? Hold on, please. So it has good depth of penetration, but resolution that one of us talked about is one of its limitations. It's actually one of its limitations. So the wide area coverage, you know how vast, for instance, the Niger Delta Basin is, and you're using the seismic data to image the subsurface across a wide area. So it gives you that opportunity to see what is in the subsurface over a large area, and then at depth as well, up to as high as up to 10 seconds, which is even up to tens of kilometers in depth. So that's one the reasons or the advantages of the seismic method. over other methods. Okay, so I'll have to log off from this one. So that's one of its advantage over other methods. So without much ado, the seismic method, we all know what a sedimentary basin is, right? Is that,
Yes, sir.
are we good? So in a sedimentary basin, we have sediments deposited in layers. Sediments are deposited in strata, or layer after layer over periods of time. And so within the sedimentary basins, we have mineral deposits, both solid minerals and minerals that are not in solid states, like our hydrocarbon. So the essence of adopting the seismic method is to have a wide area coverage within a sedimentary terrain. And so we'll be able to image the subsurface and see what lies within the subsurface, and then identify the different possible rock units and structures. Okay, so I don't know. I believe most of you have done petroleum geology in school, or petroleum geology in school, where you are taught about the reservoir rocks, the source rocks, the structures that act as petroleum traps, and the overburden rocks. That's generally what we call the petroleum system elements. So I won't be going into that, but one thing I want you to know or have at the back of your mind is that within the sedimentary terrain, sedimentary rocks are deposited in layers. So for our brothers that are geophysicists, who are not too conversant with who may not be too conversant with geology, let me put it that way, you have to understand that sedimentary rocks are deposited in layers, and this layering of sedimentary rocks, okay, this layering of the subsurface earth materials is what makes it possible for us to be able to apply the seismic method in exploring sedimentary basins. Okay, so if you apply the seismic method, like say in earthquake studies, because the earth is in layers as well, we have the crust, we have the mantle, we have the core, okay? The inner core, outer core, and upper mantle, lower mantle, and all that. This layering of the earth surface, subsurface, is the same reason why it's easy to study the earth subsurface using the earthquakes, because the seismic waves, they will definitely reflect or refract at the boundaries between these different rock types or rock units. So by the time we start diving deep into these things, I will understand why and how reflections occur at the subsurface, and that will be where we will start. If you look, your plan for the mentorship program, they captioned it seismic acquisition and interpretation, right? So I'm starting beyond acquisition. So our classes are not starting with acquisition. We are starting with introduction to the seismic method. So I don't just dive into telling people about acquisition. That is I'm sure most of you, almost all of you here know about acquisition. You know about the geophone, the hydrophone, the dynamite, and the vibrosize. All of you know that. I know you know about it. But you need to understand what happens before you start those equipments start working, or when you are using those equipments, what actually happens? What is actually happening? How is my seismic wave generated? When it travels, what happens in the subsurface? How is a seismic trace generated? Can I produce a trace? So for this our introductory path, we're going to generate a seismic trace. Each of you will be able to generate what a seismic trace looks like. And a combination of these traces is what gives us the seismic data. So these are the basic things. I start from the basics. So bear with me, relax, don't be in a hurry, and be willing to read beyond what we study or what we discuss in the class. Be willing to read beyond what we do here or beyond my slides. My slides may not be very elaborate, but when I tell you what to read or what not to read, you go back and read. So for what I shared with you, the link, it gives you a quick overview of seismology, which is about earthquakes and the types of seismic wave. That's where my focus is for that link. So when you read it, I would like you to take a step further and read about the properties of seismic wave, or of a wave generally. Generally, every wave have its properties. In terms of every wave has frequency, every wave has an amplitude, amplitude properties, frequency, period, wavelength, and all that. So between now and our next class, I want you to get yourself conversant with these things, because anything you're doing with seismic data, you're going to be dealing with these wave properties. From acquisition to processing, you'll be talking about the wave properties, frequency, amplitude, and frequency and amplitude, and velocity. Our brother talked about the seismic velocity. Yeah, the velocity of the seismic wave tells you about the rock and the subsurface. I will explain that when we start discussing our slides, because the velocity gives you the relationship between your rock and the rock property in terms of its velocity and its density and the acoustic impedance and the reflection coefficient. So we'll get to all those things. We'll break them down one by one. And by the time we finish this introductory part, which talked about the seismic method of geophysical exploration, you will be better grounded to talk about acquisition. So read up the seismic wave properties. In terms of, when I mean seismic wave properties, I mean amplitude, frequency, wavelength, and all that. Wavelength and period, what they mean, and that's generally what they are all about. So with that, having said that, I think that would be the act for today. I don't know if anybody have any question for me. I'm expecting your questions if you have any. No question? Some of us joined late. If you're joining and you didn't do the introduction, can you do your introduction now? Daniel, can you find out who and who have not introduced themselves?
Ayorinde Blessing, please introduce yourself.
Is she on the call? Blessing?
She's
Next
not.
person, please, if she's not there.
Rebecca Chioma.
Yeah, good evening, sir.
Good evening. Please introduce yourself. Your course of study, or where you graduated from. Rebecca, are you here?
Okay, yes, sir. My name is Rebecca Chama, and I'm a graduate of geology from the University of Port Harcourt.
Okay. Next person, please.
Right, Chimaroke. Chimaroke, yeah.
Yeah, I'm here. Good evening, sir.
Okay, good evening.
Yep.
My name is Wimbo Chimaroke. and I'm an undergraduate from the University of Lagos, currently studying geophysics.
Okay, geophysics. Next person.
Okay, Alima.
Good evening, sir.
Good evening.
My name is Akonbe Alima Damilola. I'm a graduate of geology from Kwara State University, Malete.
Okay. Next person, please.
All right, Yusuf Azan, are you here now?
I have introduced myself earlier on.
Yusuf have introduced himself already. He's a geophysicist.
Juliet Oluebube, yeah. Juliet Oluebube.
Okay, good evening, sir.
Yeah, good evening.
My name is Isabasi Olebibe Juliet. I'm a final year student of geology, Nnamdi Azikiwe University, Oka, Anambra State. Thank you, sir.
Okay.
Right, that's all, sir.
Okay. Okay, that's all. So, okay. So we have a good mix of both geologists and geophysicists. So, okay, that's fine. So thank you so much, everyone. So next thing I'd like to say or discuss before we conclude, our timing for the program. I understand for each week we have 2 days that was stipulated for Saturdays. Am I right?
Yes.
So that is the arrangement. Saturdays, 2 hours.
Yeah, it's 2 p.m. on Saturday.
By 2 p.m.
Yes.
Okay. 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 Okay, no problem. So the next time we'll be meeting will be by next Saturday by 2 p.m. That'll be fine. I think that will be all for now. Daniel, is there any other thing we need to talk about?
All right, please, for those that have not written the attendance, drop it on the chat box.
Okay, so thank you very much. Just have a great evening. Do the due diligence. Just read up a little on the direction I pointed you. I have my reasons so that when we start talking about other things, we will not. We will all almost be on the same page, especially for our friends in geology. Talking and reading about the wave properties. It's not something that they are used to. The geophysics students, the graduates of geophysics, I know you guys are more conversant with physics and the physical properties and all that. So for us in geology, our friends in geology, so please make sure you read up about the types of wave, the P wave, the S waves, and the surface waves types and all that. And then read up the wave properties, as I said, in terms of frequency, amplitude, wavelength, understand what it means, because these things are what controls the effectiveness of the seismic method when it comes to using them for geophysical survey, the wave properties. So that will be all for today. Thank you so much for your time.
Raising
Bear
our
with
hand.
me and okay. Any question?
Alima, please.
Thank you, sir.
Yeah.
Sir, please, would you like to recommend any textbook for us, probably that we can go through?
Textbook. Okay, I'll do a quick search. I have the platform. I can drop some links to some maybe online sites that you can look at. I will do that between now and our next class. So I'll look at things you can read. But I know you have the internet at your disposal, so you can surf the web wider than myself. So please, there's no limit to any to where you can source for intellectual materials in these topics. But I'll try to find some things and post. So you can start with the one I've already sent.
Okay, sir. Thank you, sir.
Thank you.
All right, thank you very much, Uchechukwu. It was a very lovely session, and we shared it. And just as you said, we'll go through everything that we need to go through before our next class.
Okay. Okay, thank you so much, everyone. Do have a great evening and the rest of the week.
Thank you so much, sir.
Thank you. Bye.
Thank you so much, sir. Bye.
Thank you. Bye-bye.
Bye, sir. Bye, sir.
Have a
Good
good
night,
night.
sir.
Bye.
Thank you, sir.
All right.